Hey everyone, and welcome back to PrepFusion. I'm Anish, and today we'll start the lecture 1B of this particular series of electrostatic chapter. So we'll solve few questions on Coulomb's law, and we'll also understand the superposition principle of Coulomb's law. So what is the superposition superposition principle of Coulomb's law? So it states, the superposition principle states that if multiple charges are present, the total force on any single charge is the vector sum of the individual forces exerted on that charge by all other charges as if they were acting alone. So this I have already explained previously as well, that Coulomb's law actually follows superposition principle. So basically, if I isolate, like let's say I have a charge q3, and okay, not this charge q3, let's say I have a charge q1, and the force on this charge q1 due to q4 will be independent. It will be independent. It doesn't matter this f14 vector, right? It doesn't matter if I have two charges here, if I have 100 charges here, if I have no charges here, it doesn't matter. The force due to the fourth charge q4 f14 will be same. It will be same. It doesn't matter how many charges I have here, how many charges I have here, it doesn't matter. Okay, so that is the important point that this superposition principle states. So basically f net will be the sum of the individual charges as if they were acting alone, so basically, how do we use superposition principle? We isolate each charge. Just hold on. Isolate each. Just hold on. We isolate each charge. And find the force due to a charge at a time. Okay, find the force due to a charge at a time. My iPad got crashed, so we'll start with a question. There we'll understand this concept better. A point charge q1 exerts a force F upon a point charge q2. So q1 and q2 are there, and q1 exerts a force on q2. q2 itself cannot exert a force on itself, right? It is not possible. If one other charge q3 be placed quite near q2, so let's say I have a charge q2 and q1, and this q1 exerts a force. Let's assume that both of them are same signs, so it will exert a force of f12 here, right, due to charge 1. Now I have another charge q3 that is placed quite near charge q2. So I have a charge q3 which is placed very near to this q2. So like the distance between them is very small, so the force acting between q3 and q2 will be very high, right? Very high. Okay, then the force that q1 exerts on the charge q2, then what will be the force that q1 exerts on the charge q2? So like the force has certainly been increased, right? So overall force will be very high than the previous force. Okay, it will be greater than the previous force, and your option B will be correct, and only if this was the case. This is incorrect, right? Because if you didn't read the question correctly. What was the question? Then the force that the charge q1 exerts on the charge q2, force that the charge q1 that it will exert on the charge q2 will still be same as f12. It will not change. So it will be same as f, just like previous case. It doesn't matter if this q3 is placed very near, q3 is placed very far. It doesn't matter. So here option A will be correct. It will be same as f as the previous case. Okay, it will not change. This is what the superposition concept tells us. Let's do another question. A charge q1 and q2 are placed in a vacuum at the point minus 1, 0 and plus 1, 0. Determine the force acting on q2. This is q2, right? Okay, this actually is determine the okay, this is placed here 0, 1. Okay, something is wrong. I've written this charge q1 and q2. Okay, this is q1, this is q2, this is q3. So this should be 0, 1 and 1, 0. Sorry, this is 0, 1, q3. Okay, this should be q3 actually. Sorry. Yeah, now it is fine. Determine the force acting on q2 due to charge q1 and q3. q3 is located at 0, 1. Okay, so if like the same situation, right? If they are all same charges, if they are different charges, if they are like if the signs are quite different, then how will the force affect? So I will solve for one, and again I will give the other ones as homeworks. Okay, so this first one I will break this down into two cases. First, due to like force on, okay, actually this q2 was supposed to be here only. I think there is some mistake. This q2 was supposed to be here, and q3 is located at -1, 0. Okay, and the point 0,1. Fine. So now what will be the force basically due to q1? What will be the force due to q1? This is simple, right? I will again do the same thing that I did in the previous case. So I will just copy and paste that case that I solved here, right? This particular thing, just the same case. So I will just totally copy and paste this thing, right? Totally copy and paste this thing. This was the homework from the previous case. Just what will change, actually I will change few things. I'll just copy this part. Okay, copy this portion, and the magnitudes of q1 q2 are also same. I think they are all 1 micro, 1 micro, right? 1 micro and 1 micro, yeah. So they are all same only. So what will happen here, again I will assume x vector. So the direction, they are all like charges, right? So again the direction of the force will be line joining these 2 points, and it will be either here or either here. Okay, because they will repel each other basically. So it will be, again I will assume a x vector here. This is r2 vector and this is r1 vector. Okay, so yeah, f21 will be this, and we will get our answer. Now what about f12? What about f12? So f12 will be something different. So f12 is f23 basically, f23. So f23 will be a bit different. So here, right, the direction of the force, again they are positive charges because all of them are plus, right? +1. So this was also plus, right? Yeah. So this direction will be something like this. Again the line joining these 2 points, and they will repel each other. Again I will assume this is what, r3 vector, right, in this direction. This is r2 vector in this direction, and let's say this vector is some x vector. So again I can write, all this is corrected, yeah. Again I can write r3 vector plus x vector equals to r2 vector. So my x vector will be r2 minus r3 vector. So simply it is equals to, what is r2? R2 is ay cap minus, this is r3 is minus ax cap. So this will become actually plus ax cap. Okay, minus of minus becomes plus ax cap. So the unit vector of r23 will be simply ax cap plus ay cap divided by √2. Okay, so this divided by √2, then what will happen? Then f magnitude, what will be the magnitude? Magnitude will be same again. It is in vacuum because they have mentioned this is in vacuum. So k 9 into 10 raised to power 9 into q1 q2, again it is 1 into 10 raised to power minus 6 whole square divided by r square, right? What is r? R, again the distance is again under √2, right? Distance, this is under √2 because this square plus this square, this will be under √2 whole square. So again this will come out to be 4.5 into 10 raised to power, this is minus 3, right? 10 raised to power minus 3. Okay, so the direction, like here the direction will be f23 direction will be simply, I can do this very fast as well. I'm just like following all the protocols, all the steps. That's why I'm doing this slow, but you can do this fast. Okay. So बस इसमें ओके इतना ही होगा. Then like what will be the F net? What will be the F net basically? So F net will be basically force on 2 due to 1 plus force on 2 due to 3. So if you observe carefully, this is minus ay and this is plus ay. So ay gets cancelled. Only x component is present. Okay, only x component, because if you observe, due to this particular charge, right, it is repelling in this direction. Okay, fine. And due to this particular charge, it is repelling in this direction. This should be minus x. Actually, why is this plus x? What is happening? Why is this minus y? Okay, sorry. There the charge direction was different, right? This should repel each other actually. Sorry. This should be actually, this is R1 plus x should be equals to R2. Okay, R1 plus x. Sorry. This will change, right? That's why I am observing that something is wrong. So this will be R2 minus R1 actually. This will change. This will be ay will be plus and ax will be minus. Okay, fine. And here this will also be swapped. Okay, sorry for that. So this will be the case. So if you observe carefully, that the ax component, right, ax component will cancel out and ay will remain twice of ay. So basically my answer will be 9 into 10 raised to power minus 3 ay divided by root 2 newtons. So this will be the overall force due to the whole system of charges due to Q3 and Q1. Okay, so I hope you understood. Now the homework for you is B and C. Okay, B and C you try by yourself. So let's now start this question. So this is another question. Mainly we will solve questions in this lecture. 4 identical point charges are positioned at corners of a square. So I have a square, like in electrostats, right? Once you read the question, simultaneously you try to draw the figure as well. So I have a square. Okay, and this will be 4 point charges. They are positioned on the corner. They are identical, right? All of them has Q charge. I don't know the sign, but all of them have same sign. Okay, Q. A fifth point charge is placed at the center of the square. So a fifth point charge is placed at the center of a point charge. Net force experienced by the fifth point charge. What will be the net force experienced by the fifth point charge? So like it will be a superposition effect. Now just remember this thing, whenever there is symmetry, right, whenever there is geometric symmetry, the net force will be 0 actually. Why? Because like this you don't need to solve using superposition. This you need to solve with simple brains. So here the force due to this Q charge, right, will be in this direction. Just hold on. Will be in this direction. The force due to this Q charge, right, will be in this direction. So these two will exactly cancel each other, and the force due to this Q, right, will be in this direction, and the force due to this Q will be in this direction, and the charge itself cannot obviously exert any force. If I just move the Q, so all of them are cancelling each other out, right? All of them are cancelling each other out. So net force F net will be simply null vector. Okay, it will be simply null vector. It doesn't have any direction. Net force will be simply 0. So with geometric symmetry, if your figure follows geometric symmetry and obviously all the charges are same, then the net force will always be 0 if the charge that is placed in the center of a figure. Okay, regular shape meaning square, circle, polygon, regular hexagon, all those things, right? Let's solve next question. This question is 2 point charges plus Q plus 4Q are separated by a distance of L. This should be actually L, so I should write this properly, L. Where should we place a third charge? Where should we place a third charge on the line? Where should a third charge be placed on the line joining the two charges in such a way that the entire system is in equilibrium. Why should we place the third charge in such a way that the entire system is in equilibrium? Why should we place that charge? Okay, so basically, where should we place, well, okay, so just hold on. Where should a third charge be placed such that the other two charges, such that the, just hold on. So basically net force, entire system is in equilibrium, nothing is moving. So I have one charge here plus q and another charge here plus 4q. Okay, so if I join these two lines, then what can I say? There will be some force. So I want to place a third charge. Okay, I want to place a third charge. I don't know where. Let's assume the distance from the smaller charge is simply x. Okay, this distance is x and this whole distance is L. So this distance will be L minus x. Okay, so basically the force on all of the charges should be 0. So if the whole system is in equilibrium, so the force here also should be 0. So basically what I can write, what is the force due to this? It will be somewhat in this direction, right? If the, let's assume, I don't know, okay, I don't know like the signs, I don't know the signs, but what I can say is, if okay, what I can do is, first of all, we can do two things. One thing is, these two are same signs, right? These two are same signs, so both of them will repel. Okay, so I need something that will give force in this direction to this 4q and something that will give this direction in this direction. So obviously q has to be negative. Q has to be negative. Okay, this I have established. Why? Because the force due to plus q on this 4q will be in this right hand side, and force due to plus 4q on this q will be on the left hand side. But I need to make it 0. So obviously it needs some attraction. So this q has to be negative so that it can attract, or q has to be of other side, opposite side, right? Q has to be negative. So this much I have established. So obviously q is negative. So what is the force in q total? It will be q, like due to this plus q, the force will be in this direction, and due to this plus 4q, the force will be in this direction. So both of them will be opposite. So this will be qq divided by r square, that is x square, and there is k as well, equals to k into q 4q divided by L minus x square. Okay, because this distance is L minus x. Now I will simplify this. So if I simplify this, q will get cancelled, and what I can say is L minus x whole square divided by x square equals to 4. If I take the under root on both sides, right? If I take the under root on both sides, or if you want to, okay, we'll take the under root only. This will be L minus x divided by x equals to 2. So L minus x equals to 2x, or x equals to L by 3. Okay, this is my L value. Now if I would have assumed this minus, what would happen? L minus x equals to minus 2. This would have been L minus x equals to minus 2x. X would be equals to minus L by 3, which is not possible, right? X has to be greater than 0. X cannot be negative, so not possible. So we'll choose this, obviously. So here x is L by 3. This much we have established. And what is needed? So this we have established, x should be L by 3. So the distance from which it should be placed is L by 3. Now what will be the value of the charge? Value of the charge also I can determine. How I can determine? I know the net force on this q is 0. So what is the net force on this q? It is q into capital Q divided by x square. Should be equals to this force, right? That is 4q into q. K is also there. K 4q into q divided by L square. So capital Q by 4 equals to x by L whole square. What is x by L? X is L by 3. So Q is Q by 4 equals to 1 by 9. Okay, so Q equals to 1 Q is also there right here. Yeah, so this will be equals to 4 by 9. 4 by 9 Q. Okay, 4 by 9 Q. So this will be my charge. So I hope you understood this point. Now, yeah, sorry for the interruption. Actually, here, right, whenever we write this formula, this direction is already taken care of. So whatever I'm computing, I'm just computing the magnitude of Q, right? So Q will be actually equals to minus 4 by 9 Q, because I have already assumed that this is a negative charge and the direction of force is attractive. Okay, that is already assumed. So that's why the sign is already assumed. Sign will be negative no matter what. Okay, sign will be opposite to the original charge. Let's solve this next question. This question is very, very interesting. So we have a question here. Consider an electron, a neutron and a proton initially at rest. So I have a electron, neutron, neutron is there, and proton. Okay, this is proton basically. Initially at rest and placed along a straight line such that neutron is exactly at the center of the line joining them. So neutron is exactly at the center. This is a gate question. Okay, these type of questions do come. And recent question this is. At t equal to 0, the particles are released. So at t equal to 0, all the particles are released, but are constrained to move along the same straight line. So they are constrained to move along the same straight line only, the line joining them. Okay, which of this will collide first? So will electron and neutron collide first, or neutron or proton will collide? Which of them will actually collide first? That is the most important component here. Okay, so how do you know which one will collide first? First of all, neutron has zero charge. Okay, neutron has zero charge. So this doesn't have any force. F neutron is 0. So this will not move. Only electron and proton will move. So the force acting on both electron and proton will be same, but in opposite direction. So it will have some force F. Okay, as they are of opposite signs, they will be attractive in nature. This will be F. So both of the force will be same. But what else do you know? Okay, one thing I have. What else do you know? We know force is equals to mass into acceleration. Now force is same, mass is different, acceleration will be different. So I can say force on electron divided by force on proton will be equals to mass of electron divided by mass of proton into acceleration of electron divided by acceleration of proton. So from this I can say that these will be cancelled because they are same only according to Coulomb's law. Same force will be acting, right? So mass of electron is much lower than the mass of proton. Mass of proton is almost equals to mass of a neutron. Okay, so mass of proton is very high. So acceleration of electron by acceleration of proton will be equals to mass of proton by mass of electron, or in other words I can say acceleration of electron is greater than acceleration of proton. So this electron will move faster. Electron will move faster. Okay, electron will move faster. So if electron moves faster, that means what? That means that it will collide to neutron faster because it is also moving but slower. So it will collide to neutron faster. So electron and neutron will collide first. Okay, then proton will collide, right? Then what will happen? I don't know. But electron and neutron will definitely collide first. Okay, that is for sure. Okay, so I hope you got this question. This question is a very good question. This is like a basic JEE mains question, right? This question came in GATE. Okay, so yeah, pretty simple question. You should be able to solve this. Next is point charges are placed at the vertices of a square. Okay, fine. With length L. So the length of the square is L. As shown in the figure. Determine what should be the sign of the charge Q and the magnitude of the ratio Q by Q such that the net force on each charge Q is 0. Net force on this is 0. This can be something else, but net force on this Q charge is 0. So one thing I know, we have to apply superposition. So first of all, if I observe here that due to this plus Q, right, it will have a repulsive nature, and they have provided us the sign of Q. Okay, Q sign I don't know. I will determine the sign. So I will, this much I know that these have same signs, right? These are same charges only. So obviously due to this capital Q, I will have a repulsive force, right? I will have a repulsive force. Now obviously I need to make the charge 0. I need to make the force 0. If I need to make the force 0, I need to apply a force in this direction. So basically I need a attractive force from this Q's, right? So obviously they will be of opposite sign. So if Q is greater than 0, then Q will be less than 0. Basically that is the case. If let's say Q is less than 0, this is for Q greater than 0. Okay, if Q is greater than 0, then there will be attraction, and if Q is less than 0, then small q has to be greater than 0. Basically there needs to be a attractive force. That's it. There needs to be attractive force. That's it. Nothing else, right? So that is the thing that we have identified, okay, to make it 0. This much we know. So what are they asking us? We have find out the sign of Q. Now we have to find out the magnitude of the ratio Q by Q. So how do we find out the magnitude of the ratio? So one thing I know, let's assume this as theta. Okay, this is theta. Let's assume this as ax cap, okay, in this direction, and this as ay cap. Okay, so I can break this down into two components. So the force here, right, attractive force in this direction will be, in the x cap direction will be due to this Q, and force in the y direction will be due to this Q. So overall force in Q, right, overall Q net, okay, overall Q net, because what is this angle? Basically, can you tell me what is this angle? Can you tell me? So this angle, right, is the line joining the diagonals. You have to have a bit of intuition. So this overall angle is 90. So this will be half, right? Diagonal angle will be simply 45 degrees. So this angle will also be 45 degrees. Okay. So this force will have two components, one in the ax cap and one in the ay cap. So F in the x direction, F due to the capital Q, right, will be basically F vector cos theta and F vector sin theta. Okay, this is in the minus ax cap direction, right? So this will be simply minus this, what? This is k q square divided by what? Diagonals length whole square. What is the diagonal length? This is length of L. So this will be length of root 2 L. So this will be k q square divided by 2L square. Okay, this will be simple in the minus ax cap direction. Okay, then in the plus ay cap direction, same thing. This will be same only. Okay, but in the plus ay cap direction. Now this has to be cancelled out by this q, and this has to be cancelled out by this particular q. So bit of intuition you need to have. No other choice, right? Bit of intuition you need to have. Okay, so basically what I can say is k q q divided by, what is this distance? This is L, right? So this will be L square should be equals to k q square divided by 2L square. So here capital Q will get cancelled. So q by capital Q will be equals to simply 1 by 2. No, it won't be 1 by 2. This will be a mistake because you have made a mistake here. What mistake you have made? So just hold on a second. Let me check if everything is recording here. Yeah, everything is fine recording. So what mistake have you made? You have forgotten, like, this is the overall force, right? Overall force. But I have to take the component of this force. This is F cos. This should be into cos 45, right? And this is into sin 45. This I have forgotten, right? So here actually a extra 1 by root 2 will be present. Okay. So this I will copy. One thing you forgot here, actually into 1 by root 2 will also be present. Okay, so this will be equals to q by capital Q divided by 1 by 2 root 2. Okay, So this will be 1 by root 2. This will be the answer to this question. Now the part B, right? This is the part B. So this like I have broken it down. Part B is the homework for you. B is the homework that you try to solve by yourself. This part, right? What if I want to make the net force on each Q equal to 0? Then what needs to be the ratio of Q, small q by capital Q, and what needs to be the like sign of Q? That also you identify, right? That also you do in the next like in the homework. Okay, so now let's solve this next question. So this next question is also interesting. Here we have 4 identical positive charges, each with a value of Q. We have 4 and placed at 4 corners of a square with side length L. So say this thing is same only. Here just all of them are identical. Okay, and they have a charge of Q. Side length L. A unit positive charge with mass m is positioned at point P at a height h above the center. So this is actually a 3D figure. So actually what I should do is I should draw this properly. So this, right, this will be a 3D figure. So I have a square. And at height h, this is point P where a unit positive charge, right? Unit positive charge of 1 Coulomb is positioned. Okay, Q equals to 1 Coulomb. So all these are Q, 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 L, 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 L. Okay. So what should be the value of Q to keep the unit charge in equilibrium? Okay. So first of all, you have to understand this is an earth actually. So this charge Q, right, will have its own mass. If this charge Q has its own mass, I don't know the mass yet. Mass of an electron is what? Mass of an electron is 9.1 into 10 raised to the power minus 31 kgs. But this has multiple electrons. So this will have its own mass. Okay. So due to this mass, right, in this charge Q, there will be some force. Okay, mg. And obviously all these 4 charges will actually give it some repulsive force. Okay, in this direction like this. This is a very symmetrical case. The charges will give forces in this direction. Okay, so what will happen is that all the force in the top will get added and all the force in the other components will get cancelled basically. Okay, that is what will happen. So what is this angle basically? So here, like I will explain it. Let's say this is the point, right? So this will provide some charge, this will provide some force here. Again, this will, if you are able to visualize, please tell me. This, again, this will provide some charge and this will also provide some charge. Okay, so what will happen? All the other components will get cancelled, only the top component will be left with. Okay, and what will be the angle basically? How will I determine the angle? The angle is very interesting, right? So how do I determine the angle? So I need to determine this okay, this force, right? I need to determine what angle? This angle, right? Basically this theta angle. This angle is same as this theta angle. What is this? This is if this is L, right? This overall diagonal connecting will be root 2L. This overall diagonal connecting will be root 2L. This will be L by root 2. Like you have to have a bit of visualization here, right? L by root 2. And what is this height? Height is h. They have already given me the height is h. So what will be this theta? Theta, right? This distance will be what? This distance, let's name this distance as r. So r will be under root of L by root 2 whole square plus h square 1 by 2. Okay, so this this will be what? So R is this. What is theta? So theta is basically, if I write tan theta will be height h by L by root 2. So this will be root 2 h by L. Okay, this will be root 2 h by L. So that is the case. So I need to find out this vertical component, right? This vertical component. Horizontal component is getting cancelled out. I just need to find out this vertical component, as the horizontal component, due to symmetry, the horizontal component will get cancelled. Okay, only vertical component will be remain. So all four will have additive vertical component. So this will become F net on the charge q will be F due to gravity minus 4 times F due to the vertical component. This has to be equals to 0. As mentioned, the charge needs to be stationary. So what is the vertical component force actually? If I observe, vertical component force will be simply F sine theta, right? Because this force, right? This force is F cos theta in the horizontal direction, and this is in the vertical direction, F sine theta. Okay. So what is sine theta? What is F? F is basically K, Q, and this is also Q, right? K Q square by this distance, R square. R square is what? This, right? This. So I'll just write here R square into sine theta. What is sine theta? Sine theta is actually height upon base, height upon hypotenuse. So this will be, height is h upon r. Okay, this is sine theta. So this will be kq square h by r cube. What I need to equate? I need to equate this kq square h by r cube equals to 4 times this should be equals to the force by the mass. Now what is the mass of this thing? Can you tell me the mass of this thing? Mass, right, will be n times me, like the mass of a single electron. So how many electrons I have? This is a 1 Coulomb charge. So if this is a 1 Coulomb charge, I have to find the number. Number will be simply 1 divided by 1.6 into 10 raised to power minus 19. This into 9.1 into 10 raised to power minus 31. This will be the number of electrons, and this will be the mass of those particular electrons. Okay. So if this is written over here, mass is this. So I will just directly copy and paste this for here into gravity basically. What is gravity? Gravity is 10 meter per second. So mg I can write 10 meter per second. Okay, whatever you wish to, okay. So now what have they asked? They have asked is what should be the value of q. Okay, so like in terms of h, l and all those things, so value of q, right, in terms of h and l, I can say. So basically you can derive the value of q from this. Okay, from value of h, l and r cube, all this will be known to you. Just the value of q you have to write, and k also is known, 9 into 10 raised to 1, 9. Okay, so from this you can derive the value of q. Okay, this is a very good question. You should actually practice this again. Just electrostat, right? Few questions is a bit hatke, basically means like you have to think out of the box. Here symmetry is happening. Basically all the vertical like horizontal components are cancelling each other out. Only the vertical components are left with. Okay, next let's do this question. Okay, so this question is the last question. Basically here we have two identical metallic spheres initially carrying unequal but opposite charges. Two identical metallic spheres initially carrying identical but opposite charges. So this is q and this is minus of q, are placed 0.9 meter apart in the air after being brought into contact and then separated again by the same distance. So they are 0.9 meters apart initially. They they are contacted with each other and then separated. So if they are contacted with each other, basically the charge will be divided between those two. So both of them will have how much? Q plus Q, 0 charge, right? 0 charge. So this will also have like basically Q minus Q by 2, that is 0. So this also has 0 charge, this also has 0 charge, and this is 0.9 meters. Simply the force of repulsion between them is 0.025 Newton. Calculate the final charge on each of the spheres. So what will be the two identical spheres but of opposite charges. Okay, carrying unequal. They are not carrying equal. That's why I thought the question will be redundant then Q1 Q2 actually, but opposite sign. So finally the charge will be Q1 Q2 by 2, Q1 minus Q2 by 2. Okay. So next what they are telling, after being brought into contact then separated again, the force of repulsion between them is 0.25. Force of repulsion will be here or here. It will be here, right? After they are coming into contact, the signs of the charges are same, hence they will be repelled with each other. So obviously repel with each other. So obviously what will happen is that basically they will be repelled here, okay, after again coming into contact. So this force they are telling us 0.025. Calculate the final charge on each sphere. So like let's assume this charge equals to some charge Q. Okay, so the magnitude of the charge they are telling us 0.025 Newton. So K Q square by the distance is 0.9 meter square should be equals to 0.025. K is how much? So K by 0.9 whole square equals to 0.025 divided by 9 into 10 raised to power 9. Okay, so what I can do is if I just compute this, right, if I just find out the values, I'll quickly find it out. Actually, if I take the under root of this actually will become 0.5. This will become 0.5. This will actually not exactly be equal. So what I can do is I can add a 10 here and a 10 raised to power minus 1 here. Okay. If this is 0.25, okay, yeah, this will become symmetric actually. This will become 0.25. This will be 9 into 10 raised to power 10. So if I take the under root now, this will be Q by 0.9. This will be 0.5. This will be 3 into 10 raised to power 5. So now if I find it out, what will this value be? 0.9 into 0.5 divided by 3. So 1.5 micro coulomb. Okay, 1.5 micro coulomb. So this is the final charge that they will possess, and this is what in the question they're asking, calculate the final charge on each sphere. So this type of calculation, right, from here to here, you have to have a bit of practice and knowledge. So I didn't use the calculator. The calculator would have been very complex. To avoid using the calculator, I just simplified this, then I solved this. Okay, so these type of tricks you should have in your mind while like going for any competitive examination. These type of tricks you should be able to understand. Okay, so yeah, that's it basically for this lecture, and in the next lecture we'll learn about electric field. That is a second concept of this particular chapter, electrostatic. We'll learn about electric field and how to compute electric field due to different charge distributions. So yeah, thank you for watching, and I will see you in the next lecture. Until then, happy learning.